Morning all. I'm going to talk about trucks. So thank you to MLA, LiveCorp and the Australian Government and CSIRO as well for funding this work. We've just started, so we're not as far ahead as we thought we'd be when we were coming to give this presentation, but we can give you some insights from where we've got to so far. So this morning I'm going to talk about the problem as we see it, some of the solutions that we're looking to get, and then also the progress we've made so far, and a bit of a call to arms in terms of the next steps, because we need some input from the industry and from people in the supply chain to be able to make this work for us. I took this photo last week hanging out of a window of a plane going into Surabaya, just looking at some of the investments in infrastructure into Indonesia. So there's a new toll road being built just outside the city. It's sort of an example of how there's major investments in infrastructure in many of the receiving markets that we're going into. But if you have a look a bit closer, there's no connecting roads to it. So sometimes infrastructure goes in the right place, it just needs a few things to make it work better. What's the problem? It's a problem that's not just a live export industry problem, it's an agricultural industry problem. We have complex, long and sparse supply chains. So we do thousands of kilometres of distance between origin and destination in terms of our products. We tend to have shared infrastructure that is used by multiple users, but also there's a need for specialised and dedicated infrastructure that doesn't generally always get the investment it requires, and the operating and maintenance costs aren't always borne by the people who use it. For this particular industry, in any export industry, there's limited port and shipping, and again, it's a competitive market, but we're also at the end, in a sense, at the end of the world, so we're also in areas where there's not necessarily a lot of flow of freight, so it makes it difficult to mobilise shipping. And then lastly, as you would know, we have seasons. So we have a wet season starting in the north soon. There's regulations that change sometimes rapidly, and markets can be disrupted and change rapidly as well. So we need to be responsive to those in terms of the way that the market flows and things flow through the supply chain. CSIRO's been working on this problem for quite a while now. So starting back about 7 years ago, we started looking at across all of agriculture in terms of how do you deal with transport issues. So one of the major costs in agriculture, in terms of the product, about 40% of the price of a product when it lands on a shelf is the transport costs. So ideally you'd want to optimise that. Any saving that you can make will go back to those people within the supply chain and ultimately make a cheaper product in market. So we started building the road network in terms of a model, so trying to understand where the roads and the rail is in Australia, understanding what the capacity of those are and how they're constrained in terms of their operational areas. So do we have roads that are, while they are highways, they only allow a particular type of truck on them? We then looked at what the vehicles were. So in this case, it's looking at all the different types of trucks. This is the land-based side of it, I should say. And then we looked at how people optimise their decisions in terms of selection. It involves people, so the decisions aren't always optimal. Sometimes logic doesn't always come forward, but we take account for that as well as the way we do this in the modelling as well. Looked at all the commodities, so we've mapped all of agriculture now across Australia to understand where all the enterprises are and where the demand is coming from. So where do those products go from and where do they come to? As well as looking at inputs. So in many of the industries we work in, inputs are one of the major limiting factors and costs that we need to deal with in terms of efficiency. And then we also looked at what happens post-processing or post-harvest and looked at all the destinations that those things go, including ports. And then you start looking at the cost of operating. So we do a ground-up costing. It's not a commercial costing, but essentially that allows you to compare between different options about how you might improve this. So if you think building a new bridge somewhere is going to improve the cost or the efficiency, then you're comparing the same thing as if you decide to change a regulation on whether that road can be a Type 1 or Type 2 road trains. And then you can look at how efficient can you improve those supply chains and what's the cost of doing that in the system, and is it worthwhile? In a sense, it's a simple system. You take an origin, so in this case, somewhere in the West Kimberley, some animals are being moved out of that area and their destination is in an abattoir or feedlot in southeast Queensland. The optimum route would be the straightest route, but that's not the route that gets selected. So what we do is we take into account what the different types of roads are and what would be the inefficiencies that would then be in place. So if you have to break the trucks down going from Type 2 to Type 1 road trains, then you would preferentially choose to go around that if you could. You don't go directly through the middle of Australia because there's no sealed roads. So in this situation, they've chosen sealed roads. And in this situation where we were looking at the impacts of biosecurity regulations, if you took away the regulations around the tick line in Queensland, then you would go straight through the tick line and to the destination. But in reality, you would go around if you wanted to get to that feedlot, or you would stop and be cleared at that point where the tick line is around, I think it's probably Hewenden or somewhere like that. So wherever the dip is there, you need to go through and be cleared, and there's an additional cost of doing that. So in this case, we were comparing what would happen with those regulations if you changed them, and then how would that optimise the flow. You can do that with any scenario. So in this situation, in this industry, you can then look at what would happen if you change access to ports, change the way that registered premises are located, or change the regulation controlling the time that things are held in particular locations. So we've only been into this a couple of months now, but we've first started by looking at what's been happening in the last few years in terms of the flow of cattle from properties or registered premises to ports. And we've mapped it in terms of density. So we're looking at the freight density here. So if you look at this map, any line that's dark is a road that's being used a lot. So essentially you can look at Darwin Port towards Fremantle, and then in the areas around Victoria and Townsville where you're getting animals moving to port. So it's quite a sensible movement. The lighter lines are coming from property and going into places such as registered premises. So you start to get a sense of where the important parts of the system are for this particular industry. This is both cattle and sheep in this situation, and only in the last 2 years. So we've only looked at the last 2 years of information to have a look at what's happening most recently. Now, keeping that in mind, if you compare that to all agriculture across Australia, you see that the ports that we see as important for this industry aren't necessarily the ports that are important for all of agriculture. So when you actually look at all of agriculture across all of Australia and look at what the transport task is and where are the important roads and freight destinations, you see that the eastern bit of Australia and the wheat belt of Western Australia are by far the most important parts. So in comparing and making a case for where you might make investments in improving agricultural transport, you need to bear in mind that there are other competing users in the road network. And then on the top, I suspect it's your right-hand corner, you'll see a coloured map. You then see the density of where trucks are leaving properties. So the majority of trucks are leaving the places where the majority of properties are. And that's the network that would get the most attention in some situations. The second part of this is we've started to look at what are the costs. So in using that model, we were able to build up from the ground what would be the transport costs in terms of getting animals from destination to port, and then from a registered premises, and then from that registered premises onward to the port. The cost is in part a relationship of the distance that's travelled, but also in a relationship to the barriers that are there. So overall, the cattle transport in 2014 to 16 costs about $40 million in terms of costs, and the most expensive port to get into is Darwin. And that makes sense in a part because of the distances that are going there. So there's longer distances to port that are being traversed in terms of that market. Also looking at sheep, you again look at what are the most expensive ports, and I misled someone today. I said Fremantle was the most expensive, but in fact it's Portland. And again, it's a relationship to the distance to a port, but it's also a relationship in terms of what happens in that travel distance. So can you get more efficient, higher performance vehicles into that port, or do you need to break those vehicles down once they come off properties? And that all adds to the cost, and that gives you the situation where you can get some efficiency. So that's the first part of it. We've started to try and understand the costs. We'll start breaking down where those costs are and attribute them to parts of the journey to understand where there's efficiencies and that can be made and gains. The second bit was to start talking to some of the industry representatives and asked them where along the supply chain do you see bottlenecks, inefficiencies and barriers? And we have 5 observations that have come out of those discussions so far. The first one is that most of the inefficiencies, bottlenecks and barriers are somewhere else and they're caused by someone else. And in a sense, that's a reflection of what's actually happening. You control your part of the supply chain, but you have very little control of someone else's part of the supply chain. So you will observe how efficient you are, but there will be other parts of the supply chain that will hold you up. Getting into a bit more detail, the other parts that we see is that there's physical infrastructure constraints. So we've seen this when we've looked at all of agriculture, such as road limits or restricted access, and some of those are sensible and others aren't. And then there's other things such as cut-offs due to seasonal conditions, which again are very difficult to manage, but in terms of scheduling, you can start to understand how you might be able to schedule movement of livestock to account for those things, if you can actually break down where those costs are and the time of year that you're moving. The other things that we see are operational constraints that are placed on very adequate physical infrastructure. So the physical infrastructure around ports, as an example, and I'm not giving any particular port, might be that you have scheduling preferences, so that you have your ships coming in, but there's this preference to schedule against you, and that will create an inefficiency. Or you'll have access issues to port that aren't controlled by the port operators around things such as curfews. So there's some local governments who put into place curfews around ports that aren't related to the actual operation of the port. So the port would be efficient if it was not for that curfew. Or there's particular things such as local roads that don't allow high-performance vehicles to make full access to those ports. The one that, and probably not surprising, there's some regulatory inefficiencies. Some of those are around the duplication of approvals, and others are around the sequencing of approvals that cause delays. And of course, there's always the imposition of new approvals. So we've been working through some of those approval decision-making processes in trying to understand where could you actually get some efficiencies in that. And there's many examples where that might be. And there's also many reasons why those things happen in a particular order. But some efficiencies and gains can be made. And there's significant costs if this is on the shipping side in terms of delays of loading and ships being dockside with nothing happening. And then almost universally, people were talking about ports and the infrastructure and the operational constraints around them. So that's a re-emphasis of that as one that comes up in multiple occasions. And up until now, we haven't really been looking at that. So the majority of our work's looked at the land transport side of it. So we're starting to see whether or not these are areas where you can make particular gains. Oh, there's one more, sorry. Is around the inputs. So this is an area that we actually see in many of the other intensive livestock industries, that input costs are significant in this area. So if you're trying to get fodder, bedding, bunker fuels to ships, there's significant costs and delays that are associated with that. And sometimes that's in terms of where the positioning is. So the fodder's in one part of the country and the ships are in another part of the country. And there's some significant savings that can be made and efficiencies in that around the scheduling and the access to those resources and getting them onto ships. So that's a checklist of where we've got to so far. What are we going to do next? I suppose essentially we'll basically continue to do this, start to talk to the particular operators around and the individual actors within the supply chain and start to understand where those inefficiencies are and what you can actually do about them. We've also started to map the sailing times, port times and queuing to try and understand where along so this is the last 6 months of data for cattle. So we've got all of the recorded shipping times that we can find in all the records at the moment. So we just took the last 6 months for today and basically looking at how long those journey times are. So some of the journey times are longer than you'd expect, but a lot of those might be because of multiple destinations and multiple offloadings. So trying to understand where they are and whether or not there's efficiencies and gains in there. And some of them could also, are obviously around the inefficiency at port, around the receiving port. So the second element of what we're doing in this is looking at what happens in some of the most important receiving ports. So we've started doing what we've done in Australia to Indonesia with the Indonesian government and trying to understand how can you improve transport efficiency in Indonesia. There's a few differences, clearly, between Indonesia and Australia. There's a lot more roads, a lot more density of roads. We have inter-island transfers, so that's not something that we have in Australia, apart from Tasmania, that we need to deal with. So we have different vehicles. We don't really have a train network, but we certainly have different types of vehicles and costs related to using them. Indonesia is well, I don't know if you call it a world expert, but they do congestion very well. Not something that we deal with in Australia very often. And there's also geography in Indonesia that there's mountains. We really don't have mountains in Australia. So there's some constraints in terms of operating and efficiency of trucks getting around the country as well related to the geography. We've also followed we were lucky enough when we were there to follow a dispatch of a ship. And so we've started to look at some of the process flows around ships. So the top line there is basically the shipping time it took to offload a 3,000 head from a ship in Port Priok. They were using one ramp and they had reportedly 100 trucks ready to go. So it took them about 36 and a half hours to offload that ship. We followed the trucks along and looked at how efficient they were to get to feedlot. And they reported, and it was accurate, that there was a bridge that had been washed out recently, 9 months previously, and hadn't been repaired. So that had added additional time around the return journey in terms of the trucks coming back and offloading the ship. If you improve that bridge, so you actually reduce the journey time, which is the third one down, you actually see about a 10-hour reduction in the travel time and the time to dispatch from the truck. So if you simply repaired the bridge, which would have multiple benefits for the local community and others, then you have a reduced journey time. If you simply increased the amount of animals you could put on a truck, so you went from 13 to 17, then you would have a small reduction in journey time, because essentially you don't have many reduction in the journey. So that while that would seem like a sensible thing to do, it's actually an expensive way to operate. You have to upgrade your whole fleet. So it's probably unlikely that would happen, and the gain would be relatively small. But if you look at the last scenario, if you actually had 200 trucks turn up for dispatch, you have a significant saving in the time that it would take to offload that. So instead of having 100 trucks turn up, you had 200 trucks turn up, which is probably possible. Then you can make major savings in terms of time. And so we start working through those scenarios to understand where you can get some savings in the system. It's important for us to understand how that's best presented, because we want this to have some impact. So we're looking at a couple of different ways of presenting it. One would be around those process flows, but the other would be putting this information into a tool that you can interrogate. So it means de-identifying all the data from properties and registered premises and other things, and trying to understand where along that supply chain you see time and delays and costs, and then trying to understand how you can actually improve those. And then you can build scenarios either at a business level or at an industry level about how you can then make improvements. The prioritisation is the bit that we were interested in. So how do you then prioritise that? So there's a few questions we have, and we've had some experience in working in this area, looking at beef roads across northern Australia, trying to look at we had about 70 scenarios about where money could be invested in improving beef roads across the north, and we were able to prioritise those in terms of cost versus savings. So which of those was the most efficient? And then we provided that information back to the government department who was funding it, and then they were able to choose the areas that they would invest in, not only on the basis of what we were saying was optimal, but also in terms of where they could get funding from and other things. So I think they picked option 1, 10 and 17 or something like that. But they basically knew that they weren't going to pick option 71. So they had a chance to then make a decision about what was possible and what would have impact. In doing that, you need to understand what is out of control. So congestion is something that essentially you could never deal with or invest into within the realms of what we control. And then what parts of the supply chain are in our control, but we would have very little impact in terms of what we would do to improve them. And then lastly, where the real efficiency is, bearing in mind that a majority of the transport in Australia isn't related to this industry, where can we leverage other investment opportunities? So where can we go in and make a case that improving this road or this port access will not only have benefits for this industry, but for many other industries? And so that's where I leave it. That's where we need to get to in terms of making these decisions. Thank you.